Hi student, today we are going to discuss about metal excess defect. Metal excess defect. So we know that the point defect are classified into three types: stoichiometric defect, non-stoichiometric defect, and a impurity defect. The stoichiometric defect further classified into vacancy defect, interstitial defect, Schottky defect, and a Frankel defect. This vacancy defect and interstitial defect present in the non-ionic solids, Schottky defect and a Frankel defect present in the ionic solids. The non-stoichiometric defects again further classified into metal excess defect, metal deficiency defect. Today we are going to discuss about metal excess defect. First of all, let us understand what is non-stoichiometric defect. What is non-stoichiometric defect? The defect in which the ratio of the cation to anion does not remain same before and after the defect is called a non-stoichiometric defect. The defect in which the ratio of the cation to anion does not remain same before and after the defect. It is called a non-stoichiometric defect. Today we are going to discuss about metal excess defect. Metal excess defect. So this metal excess defect arises due to the presence of more number of cations than anions. This type of defect is shown by alkali metal halides like sodium chloride, potassium chloride, lithium chloride, etc. The electrical neutrality of the crystal maintained by the presence of anionic vacancies and extra cations and electron present at interstitial positions or interstitial sites. So the metal excess defect is created due to the presence of anionic vacancies and presence of extra cations and electrons at the interstitial sites. Now let us see with an examples the metal excess defect created by the anionic vacancies. Anionic vacancies, here we are taking the sodium chloride crystal. So before the defect, the number of the cation and anions is the same. Okay, before the defect, the number of the cation and the anion ratio will be the same. Okay, here we are taking the sodium chloride crystals. So in which we let us calculate the number of cation and anions. Here the ions, here charge, here the ratio of the cation and the anion. So in this sodium chloride crystal before the defect, so number of sodium plus ions, here sodium, again the presence of sodium plus ions, so are cations 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. Here 16, charges also 16. So Cl minus ions, anions also 16. The ratio of the cation and anions 16 and 16. The ratio is 16 is to 16. So before the defect, the number of the cation and anions are same, remain same before the defect. After the defect, here the sodium chloride crystals, when heated in the sodium vapor, the sodium chloride crystals heated in the sodium vapor atmosphere, the excess of sodium ions are deposited on the surface of the crystal, For maintaining the electrical neutrality, the chloride ion present in the lattice point diffuse into the surface of the crystals. So due to this diffusion of chloride ions, there is some anionic vacancies are created. Anionic vacancies are created in the crystals. Here one anionic vacancies are created. One anionic vacancies are created. So now calculate the number of ions, the ratio of the cation to anions. Here ion, charge and the ratio. Here the number of sodium ions, Na plus 16. Okay, so its ratio is 16. And the number of chloride ions, here one chloride ions is missing. It is diffused into the surface of the sodium chloride crystals. Here the number of the chloride ion is 15, but in the electron is released from the sodium atoms, diffuses into the crystal lattice and occupies the position of the chloride ions. Here the electrical neutrality is maintained. Okay, electrical neutrality is maintained, but in the ratio of the cation to anion is decreases. Okay, here the cation is greater than anion. So after the defect, there is some decrease in the anions. So after the defect, cation is greater than anions. So what will happen actually, when we heat the sodium chloride, in the sodium vapor, the sodium atom loses one electron, forming Na plus ions. This Na plus ion deposited on the crystal surface. For maintaining the electrical neutrality, one chloride ion diffuses from the lattice point to one chloride ion. For maintaining the electrical neutrality, one chloride ion diffuses to the crystal surface and combining with the Na plus ions, it forms NaCl. Okay, this is present in the crystal surface. Okay, this chloride ion moves from lattice point. So due to this movement of electrons, or due to movement of these anions from the crystal lattice to the surface, there is an anionic vacancies are created. For maintaining the electrical neutrality, the electron diffuses into the crystals and occupies the position of chloride ions. So due to this movement of electrons into the crystal lattice, there is a vacancies are created. So such a type of the anionic vacancies are occupied by unpaired electron is called F centers. We can say F centers. So F centers nothing but it is a Farben centers. Farben center meanings color centers. So what will happen? The electron present in the ground state, it absorbs some energy, goes into the excited state. So the electron in the excited state are unstable. So when we return back to the ground state, it emits the energy in the form of light. So it will give some colors. It will give some colors. So the sodium chloride NaCl white in color at room temperatures. So when we heat at a sodium vapor atmosphere, it is yellow in color. Sodium chloride at room temperature white in color. So when we heat at a sodium vapor atmosphere, it gives yellow color. Like a potassium chloride, it is a light red color. So when we heat this potassium chloride in potassium vapor atmosphere, it gives violet color. In the same way, when lithium chloride, it is a white in color at room temperatures. So when we heat at a lithium vapor atmosphere, it gives pink color. So due to the anionic formation of anionic vacancies, it gives some colors at a heating in the presence of vapors of sodium. Sodium chloride gives, in the presence of sodium vapor, it is yellow color. Potassium chloride gives violet color. Lithium chloride gives pink color. Okay. Now let us see the extra cations and anions present at the interstitial positions. Extra cations. Again, the metal excess defect arises two reasons. One is the anionic vacancies, another one extra cations at a interstitial positions. Okay. Here the zinc oxide when heated, at a the zinc oxide in room temperature, it is a white in color. So when heated, it becomes a yellow color. Okay, when heated, it becomes yellow color. So what will happen here? When we heating the zinc oxide, so it forms Zn2 plus half O2 plus, it gives 2 electrons. So the excess of cations and electrons occupies the interstitial position of the crystal. So here one Zn2 plus occupies, here 1 electron occupies, here 1 electron occupies. So now the presence of excess of cation and anion occupies the interstitial position. So when heating the zinc oxide, it gives yellow color due to the excess of cations and electron present at interstitial site or positions. Here now let us calculate the number of ions in zinc oxide crystal. Okay, here ions, charge and ratio. Here the number of ions 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So Zn2 plus 14 plus 1 excess of cations present at interstitial position, so plus 1. Here O2 minus 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Here 14. Here total ions 15. So charges 30. Here total ions 28 plus 2 electrons, so 30. But electrical neutrality is maintained, but in the ratio of the cation to anion is Zn2 plus greater than O2 minus. Here Zn2 plus is 15 and O2 minus is 14. So cation is greater than, okay, here in this crystals the Zn2 plus cation is greater than O2 minus ions. So the metal excess defect arises due to the presence of the creation of anionic vacancies and the presence of extra cations and anions at interstitial positions. Okay, so the zinc oxide is colorless at room temperature. When it is heated, it becomes yellow in color. On heating, it loses oxygen and therefore forming Zn2 plus ions. So when we heat the zinc oxide, it loses electron, 2 electron, and forming Zn2 plus ion. The excess of Zn2 plus ions and electron occupies the interstitial positions. So this type of defect is called a metal excess defect. I hope you understand, student. Thank you.